Start.
Hi students, today we will be taking up a very important and very interesting chapter that is called thermodynamics. Definitely, we are not going to discuss all the thermodynamics together, just one portion of it. Thermodynamics has got a bad reputation. You know why? Because in the market we teachers have defamed it. Why? Because we take this topic as simply combination of few equations that students couldn't understand. They are asked to remember all those equations and apply them in the question. But thermodynamics is, very interesting chapter if you understand it. Thermodynamics is physical law, all the physical laws interpreted and that is explained. Now, look, we are coming to a point very often, and I am sure that you people have known it. This enthalpy is represented by H, and once in a fine morning you will be said that H is nothing but enthalpy, and it is H equals to U plus PV. What is U? Internal energy. P and V, pressure and volume, and they often say that enthalpy is another kind of thermodynamic property, that is the combination of internal energy and PV watt. This way we teachers represent it. But students start finding where from this definition came. That is, how it is said that H equals to U plus PV. Where from did it come? Now, this has got a origin, H equals to U plus P. Remember the first law. First law of the thermodynamics, we all know, delta U equals to Q plus W. Clear? This is what? Energy change. This is what? Heat change. This is what? Work done. Again I am saying this is energy change, this is heat change, not heat, and this is work done. That you must be wondering, change of energy is represented by delta. Why shouldn't we put to denote change of heat delta, work done delta? Because this has a history, but simply you just remember these are path functions. Path functions don't take delta sign to denote their changes. That is, path functions do not take delta to denote their change. Why this function takes delta? Because this is state function. We all know what is state function and path function. My motto is that where from this came, I want to show this. Now delta U equals to Q plus W. Now you are changing the state of a system. That's why energy is changing. And during that change, heat change, absorbed, some work done. Now let us rewrite this equation in another way. Delta U could be written as U final value, minus U initial value. That is initial state, that is final state, equals to. Now could you write it final value of Q, initial value of Q? No, you can't. Final value of work done, initial value of work done? No, you can't. Rather, you have to write it UF minus UI, let it be Q, and plus W mechanical plus W additional. W mechanical, mechanical work done, additional, non-mechanical work done. You know, very few of us know that this work is total work done. Total work done means in thermodynamics, we recognize two types of work done, that is mechanical work done, another is additional work done, that is non-mechanical. You must be wondering, what is mechanical work done? The work done by machine. Oh no. Work, mechanical work means PV work, where pressure volume changes. Simply volume expansion, volume compression. That is mechanical work done means PV work. That is expansion or compression work. So, if we recognize expansion and compression work as mechanical work, so what is additional work? Other work than mechanical work, that is non-mechanical work, that is non-expansion, non-compression work, that is non-mechanical work. That means you must be wondering, what type of work is this? Very often we come across this. Magnetic work done, electrical work done, the tube is glowing, the fan is revolving. All these things are non-mechanical additional work done. So now, if a system does only mechanical work done, then we replace this W mechanical as minus P external into delta V. So our first law comes to be delta U equals to Q minus P external into delta V. This is our first law, and the restriction what we put, restriction is that we took the system to be doing only mechanical work, that is from here to here. The condition was that W additional equals to 0. That system is not doing any kind of additional work. That's why we restricted this equation to be delta U equals to Q minus P external into delta. Clear? Now we are coming to, from this, delta U equals to PQ and P external into delta V. Now delta U, we said that UF minus UI equals to Q minus P external, let it be P only, VF minus VI. Delta V, this is step function, taking delta, rearrange this. UF plus P into VF, now minus UI plus P into VI, this becomes Q. Now, very interesting thing is that you see final state, pressure P, initial state, pressure P. So, can't we say pressure is remaining constant? Yeah. So, you must write P constant. So, P constant, that is, we are changing the state of the system where P is constant. Final P, initial P same. But its volume is changing from initial volume, final volume, initial volume, different. Now, this is what? State function, state function, state function. But all of what? Final state. So don't you think these all the state functions combined together, we cannot say any particular function. They introduce another particular function to define all these things together. This is final value, we introduce enthalpy final. Minus, these are the initial value, enthalpy initial, equals to Q, and to denote P constant, just write down P suffix of this Q. What happens? Delta H equals to QP, means enthalpy of a system is nothing but the heat change of the system during the change at constant pressure. That means enthalpy in general could be written as H equals to U plus PV. That we wrote it. This one. Initial volume, this one. Final volume, final value, this one. So in general H equals to U plus PV here from this comes, and delta H, though it sounds very foreign term to us, but this is very easily calculated. What is that? All the constant pressure processes. That is all the processes or changes that could be physical, that could be chemical, that will carry out keeping pressure constant. The heat change during those changes is actually enthalpy change of the system.